Hello, everyone. Today we're continuing with 9.3, and today we're going to talk about graphing absolute values functions as well as step functions. There are two very interesting functions that can be considered related to linear: the absolute value function and the step function. Let's start with the simpler of the two, absolute value. So the absolute value gives the size or the magnitude of the number. Find each of the following. So I'd like you to find those. So hopefully you remember that the absolute value of a negative number is always just the positive value. So the absolute value of negative 7 is 7. Absolute value of negative 2 is 2. Absolute value of 6 is 6. And the absolute value of 0 is 0. So now we're going to consider the function f of x equals the absolute value of x. So if we're doing that, when we evaluate negative 7, we say f of negative 7 equals the absolute value of negative 7, so it equals 7. And f of 4 equals the absolute value of 4, so it equals 4. So now if we fill in the table, again, we're taking the absolute value of each value. So the absolute value of negative 3 is 3, 2, 1, 0, 1, 2, 3. Now the question is, graph it. So we're going to graph that. Negative 3 is 3, 2 is 1, 1, 0. And the graph of an absolute value function will always be a v. What is the minimum? Our minimum value is 0. Over what domain interval is it increasing? So where is it increasing? It's increasing when x is greater than 0. So it's increasing from 0 on. That part that I made green. So now for exercise 3, for the function absolute value of x minus 4 plus 7, which of the following is the value of f of 1? Show your calculations. So we can do that. We're going to substitute. So we're going to do 1 minus 4 inside the absolute value of plus 7. Now we always treat absolute value signs as though they're parentheses. So we want to do what's inside first. So 1 minus 4 is negative 3. And then we take the absolute value of negative 3, which is 3. So it comes down to 3 plus 7, which is 10. Now, before we move on, I do want to show you that we can also graph absolute value functions on our calculator. So on our calculator, we go to y equals, and where we find the absolute value function is under the math, go over to number, and there's absolute value. So we can even do like the absolute value of x plus 2. And then look at the graph, and you can see that it's a v that actually moved left 2 because it was inside the function. On your main screen, if it's a tricky problem that you don't know, you can also find the absolute value. So we can do math, number, absolute value, and I can do negative 3 minus 9. And my calculator will do it for me. So now step functions. Step functions are another type of function that's related to a linear function, linear family. Considering that, so this says that when x equals 0 to 5, y is always 2. So on my x-axis, from 0 to 5, y is 2. So that's a solid dot here and a solid dot here, and it's all points in between. And then the next part is it equals 6 from 5. Oops, and I just realized I made a mistake. On that first step, it's less than 5, not equal to 5. So that's an empty circle at 5. Then when it's equal to 5, it's 6. So that's a solid dot to 10. Where it's solid dot on both ends. And that's our step function. So now that I've graphed my step function, it's easy to evaluate. I actually, in the directions, said to do it the other way, but I think it's better this way. So when f is 0, that's in my first part, so it equals 2. When f of 2, it's still 2. F of 4, that's still 4. 5 is the only one that's really I got to think about because in the top one, it's less than 5. And the bottom one is where it's equal to 5. So that's 6. 7 is 6. 10 is 6. Graph the function. Step functions can arise in real world whenever the output to a particular function is a constant over a particular range. Here's an example. At a local amusement park, the park charges an admission based on age. Graph the amount of money a person would have to pay for admission based on their age. Remember that someone who is 1 day short of 4 years old can consider themselves 3 and under. So when they're 3 and under, they're free. So their cost is 0. So if I were to graph that from 0 to 3, and if they're 1 day short of 4, so that goes all the way to 4, but it's an empty circle on 4. Because as soon as they are 4, they have to pay 8 and under is $4. So from 8 and under, meaning when I'm 8 years old, so up to 9, but that's going to be an empty circle at 9, because again, until I turn 9, I'm 8 and under. So empty circle on 9 and down to a closed circle on 4. At 4, 16 and under. So that really means 17. It's an empty circle and it's $8. So I go up to 17, 8, and I put an empty circle. And that starts at 9, so that's a solid circle. So a solid circle, flat line to 17, empty circle. And actually, my empty circle's in the wrong spot. I'm sorry, I was over at 16. There we go. Is a solid line. Then 17 and older is $12. So 17 gets a solid circle, and to the right with an arrow, because it's as old as I can go, is $12. And that is a step function because you can see it kind of makes a set of stairs. So that's the end of our video today. If you have any questions, please ask in class.